Hi dear, today we'll see the in chemistry chapter 2 acid base and salts activity 2.1, 2.2, 2.3 and 2.4. Okay, so in 2.2, so what is our aim in that activity means we are going to check whether the indicators are used to check whether the substance is acid or base by changing its color. Okay, so what is our aim? To not to check it, to observe. Okay, to observe that indicators whether it tells us a substance is acidic or basic by change in the color of the indicators. Okay, so we have already seen about the natural indicators and synthetic indicators, right? So what are the two main natural indicators? This litmus solution and turmeric, right? Synthetic solution of phenolphthalein and methyl orange we have seen, right? So here we have seen that what will be the color change when it reacts with acid and base. Do you remember that this acid when acid is poured on the blue litmus, it converted into red color, right? Red color solution, right? When the acid is poured in the red litmus, there is no color change, it remains red only. Okay, likewise in phenolphthalein, already its color of the phenolphthalein is colorless. If you pour acid, there is no change, it remains colorless only. Okay, when the acid is poured in the methyl orange, this red orange color is converted into, turns to red when acid is poured in there. So we have seen that. So same thing we have observed in the activity 2.1 with many acids and bases. Okay, so you know that sulfuric acid, hydrochloric acid, nitric acid, acetic acid. Okay, these are all acids. Okay, and we are having this base also: sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide and ammonium hydroxide. Okay, this is a weak base and this is a weak acid, you know that, right? Weak acid is acetic acid and weak base is ammonium hydroxide. We have learned all this thing. Okay, so when these acids, see, when these acids, sulfuric acid, hydrochloric acid, nitric acid and acetic acid, when it is when the indicator mixed with the red litmus solution, there is no change in the color, no change in the color. Okay, when the same acid is put on the blue litmus solution, it turns to red color, right? It turns to red color, right? In the phenolphthalein, it remains colorless. Okay, there is no change in the color, it remains colorless. And when it is poured in the methyl orange solution, it turns to red. Orange is turned to red. Okay, likewise in the when it is reacts with base, sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide, ammonium hydroxide. When you put this red litmus solution in this acid, the red litmus change to blue color solution. Okay, blue color solution. And when it is poured in the blue litmus solution, there is no change, it remains blue only. Okay, okay, when the base is put in the phenolphthalein, it changes to pink. Okay, pink color. And in methyl orange, it gives yellow color. Okay, when it reacts with when the methyl orange reacts with the base, it gives yellow color. So these are the observations of the activity 2.1. Okay, so always remember this acid is dangerous, like that, remember that. So dangerous means red color symbol. So always it gives red color when reacts with the indicators, right? When reacts with the blue litmus, it turns to red, and when reacts with the methyl orange, it turns to red color. Remember that red color, I just told that. Okay, so these are your observation. Okay, then we have one more indicator to find out whether it is a base or acid. What is that? That is olfactory indicator. What is meant by olfactory indicator? That is based on the change in the odor, we can find whether it is a acid or base, right? Some of the olfactory indicators are naturally present, right? Your activity 2.2 is to observe the olfactory indicators whether it tells us about the substances acidic or basic by change in the order of the indicators. Okay, it will change its order. Okay, so what are the things we are going to take means as a olfactory indicator? Here onion, vanilla essence and clove oil. Okay, onion, vanilla essence and clove oil. You would have smelled this vanilla essence, it gives a pleasant smell, right? But onion somewhat bad smell. So clove oil also, if you smell that, you will get this clove smell, right? So when this oil in this activity they asked us to cut the onion and refrigerate it, put small pieces of cloth in that, kept it overnight, 24 hours or overnight, and then you can get the smell on the cloth, right? So based on if you put the what happens when the HCl put on that, or sorry, acid is put on the cloth, and what happens when the base is put on the cloth, whether it retain its odor or not, we are going to check that. Okay, on observing that, when onion, okay, when onion, that smell, the cloth contain that onion smell, right? When you pour the acid in that cloth, the cloth retain its same onion odor. Okay, okay, the odor does not disappear. Okay, it retain its odor. Okay, in case the same the another piece of cloth with, kept in the onion, when reacts with base, when you put the base solution, it loses its odor. Okay, the odor disappears. Okay, it loses its odor. The same case happens in vanilla and clove oil. When these essence, vanilla essence is poured in this acid, or acid is poured in the vanilla essence, it retains its odor. Even if you put the acid, it has the same same flavor. Okay, but when you put the base in the vanilla essence, it loses its odor. Okay, it loses its odor. Same case for clove oil also. It retain its odor when you put this oil and mix the oil with the acid. When you mix this oil with the base, it loses its odor. Okay, this is your activity 2.2 observation. Okay, then we'll move to the activity 2.3. 2.3, we have learned in the theory that when metal reacts with acid or base, we'll get, what is the byproducts we get salt and hydrogen gas. Okay, that we are done in this activity 2.2, activity 2.3 and 2.4. Okay, first we'll take about 5 ml of dilute sulfuric acid in a test tube and add a few pieces of zinc granules. That is sulfuric acid plus metal, we are going to react. Okay, what is your observation? Okay, so here you are going to set up the apparatus like this. So you are going to take the dilute sulfuric acid in the test tube. Okay, and you are going to put some zinc granules, that is metal pieces. Okay, what will you, and then you are going to seal it with a cork, and you are going to connect with the delivery tube, that is bent type, and this bent tube will end up in a soap solution. Okay, so what is our aim is to, we are going to, we said salt and gas is produced, hydrogen gas is produced. Okay, we are going to check whether this actually the hydrogen gas is produced or not. Okay, how will you test the presence of hydrogen gas? When you burn that hydrogen gas, it burn with, explode with pop sound, right? So that we are going to check that. Okay, so 5 ml of, you have taken 5 ml of dilute sulfuric acid solution in a test tube and put few pieces of zinc granules, seal it with a cork and connect it to the bent tube and end up in the soap solution. Okay, so once you put, what you observe, some gas bubbles are formed, right? This gas is formed, and this gas is collected through this delivery tube and it is entered the soap. Okay, we are trying to convert the gas into bubble form. Okay, so that we can burn the bubble. It will once if you keep this candle near the bubble, it will burn with the pop sound. Okay, here the soap solution is kept to form the bubbles. Okay, convert the gas into bubbles. Okay, so if you are doing this, if you keep this candle near this bubbles, it burn with the pop sound. Okay, this is your observation. Okay, so what is your observation? Some gas are formed and the gas burn with the pop sound, right? So your observation, gas bubbles comes out and gas burns with the pops on. These two are the two observations from this experiment. And what is your conclusion? Zinc reacts with hydrochloric acid. Sorry, not hydrochloric. This we have taken sulfuric acid. Sorry. Zinc react with sulfuric acid and it gives zinc sulfate plus hydrogen gas, right? So we can write this specific equation in a general form, right? What is zinc? Zinc is a metal. Sulfuric acid gives zinc sulfate is a salt plus hydrogen gas. This is a general equation. Okay, metal reacts with acid to form salt and hydrogen gas. Clear? That's it. So we'll move to the next activity, 2.4. 2.4 here in 2.3 we have reacted the metal with the acid. Here 2.4 we are going to react the metal with the base. That's it. Okay. So place a few pieces of granulated zinc metal in a test tube. Okay, we are going to take the test zinc in a test tube. Add 2 ml of sodium hydroxide solution. Okay, the sodium hydroxide will not be available in solution form. It will be available in pellets form, small tablets like pellets, and we are going to mix with water and make the solution immediately. Okay, so you are going to add 2 ml of sodium hydroxide solution, and you are going to readily it will not react, so we are going to increase the temperature, warm the content of the test tube. We are going to heat and then we are going to follow the same procedure. So what is required? We are going to take a small zinc granules in a test tube and you are going to pour the 2 ml of sodium hydroxide solution. What you are going to do? You are going to heat this one. Okay, you are going to heat this one using the Bunsen burner. You can heat this one. Okay, once you heat it, within a few minutes you will get some bubbles. Okay, same bubbles will be formed and it is collected in this one and sent through the soap solution. Okay, sent through the soap solution. Once it's sent through the soap solution, the gas will be converted into bubbles. If you bring a candle nearer to this bubble, it will burn with the pop salt. This shows that hydrogen gas is produced. Okay, when the metal is react with the base, it forms salt and a hydrogen gas. So what is your observation? Again, gas bubbles comes out, gas burns with the pop salt. These are the two observations. Okay, then what is your conclusion? I have taken zinc plus sodium hydroxide reacted to form sodium zincate. Do you remember that? Na2Z1O2, sodium zincate plus hydrogen gas. Okay, so we can give it in a general form as metal reacts with the base to form salt and hydrogen gas. Okay, hydrogen gas. Okay, so this is a general form. When metal reacts with base, it gives salt and hydrogen gas. Okay, clear with this? Thank you.